Hello again. Today we're going to take a look at subtracting integers. Just the other day we looked at not subtracting integers, subtracting polynomials. The other day we looked at adding polynomials. Now we're going to look at how do we subtract them. And basically the way we do that is the same way we'd subtract integers. If you recall, when we first started learning about adding and subtracting integers, I told you whenever we're subtracting integers, we do that by rewriting it and adding the additive inverse. We're going to do the exact same thing when we're trying to subtract polynomials. The only thing we also have to remember here is the distributive property. There we go. The distributive property. Okay? Which means basically when I'm multiplying the sum or the difference of two numbers by a number, I can multiply each of them by that number and get the same result. So here you'll notice I showed you with a -3. Then just remember your rules for negatives. A negative times a positive gives me a negative. This was already negative, so negative times negative gave me a positive. So the thing we want to remember when we're dealing with polynomials is that we need to change all of the signs by distributing that -1 through the entire polynomial on the second one. So I'll show you that on the next board. Again, there's two different ways we can do this. The same way we added, we can either do it horizontally or vertically. Again, I prefer horizontally, but you're welcome to do whichever way works best for you. So here what I showed you was, remember, there's always an implied 1 when you don't see it. So really what I'm doing kind of when I'm changing my signs is I'm distributing that -1. And if you recall, our property about -1 says that anything multiplied by -1, all it does is change the sign. The same way that anything multiplied by 1 is itself, it doesn't change the number, all it does is change the sign if it's a -1. So really that's what we're doing. So you see how I rewrote it here? The first one stayed exactly the same, don't do anything there. This became a plus, and then I changed the signs in here. And again, you don't really need these extra pluses here. Plus and negative is the same as minus. I wrote those in there in case you were confused, but it's the same thing. Then you'll see I just underlined in color the same ones. I have an x squared and a negative x squared, so 2x squared and -1x squared. Leaves me with 1x squared. Positive 3x and a -1x leaves me with a positive 2x. So there's my answer. The other thing you can do is stack them. And what you'll notice here is I left gaps because when we're stacking them and doing it vertically, we want to put like terms on top of each other. 25 is a constant. It doesn't have a variable. 6x has an x. There's no x term up here. There's no constant down here, which is why we have blanks. If it helps you, you're always welcome to fill in those gaps with a 0, since anything plus 0 is itself. If that helps you, remember to leave those gaps there. But we want to stack like terms. So again, you'll see I've color-coded. I have, well, first let me back up, sorry. I had a minus, so you'll notice it was all written in brown. This red was where I went through and I changed it by adding the additive inverse. So I changed this to addition, which means I have to change all the signs. This was positive, it became negative. This was a -6, so I just drew the line through it, making it into a +6x. I changed the sign of everything on the bottom. Don't change anything on the top or the first one. Only the second or the bottom one gets changed, and everything in it has to change. Then we're going to combine our like terms. So you'll see how I put in green our x squared terms. I've got 19x squared and -7x squared, which leaves me with a positive 12x squared. There was nothing to add this to, so I just bring it down into my answer, +6x. There was nothing to combine this to, so I bring that down into my answer, +25. Okay, so same thing we've been doing all along, just taking a few different skills that we've learned over the year, and now we're combining it in these steps. So we'll do a few examples here. Again, we'll go through and we'll color code like terms here. The very first thing I always want to do is subtraction. So the very first thing I'm going to do is change it to the additive inverse, which means I'm changing everything in the second, nothing in the first. I have an x term and another x term. I have a constant. I don't have a constant over there. That's okay, though. And then I have an x squared term and another x squared term. So then I'm just going to combine those together. So again, we always want to write our answers in standard form, so I'm going to start with my x squared terms. Pay attention to our signs. I have a -x squared and a -2x squared. So -1 and -2 give me -3x squared. Here I have a positive x and a positive 2x. So 2 and 1 is 3x. And then there was nothing to combine my minus or negative 5 with, so that just gets brought down to my answer. So my answer is negative 3x plus 3x minus 5. Okay. Again, on the next one, we're subtracting. Very first thing I always want to do, change it to addition, change all of the signs of all the terms in the second polynomial. So I've changed all 3 of those signs to their opposites. Okay. So again, let's just see what we've got. I've got a constant and a constant. Got an x squared. I don't want to do that in my marker. Got an x squared and an x squared. And I've got an x term with nothing to combine it with, but that's okay. It's not a problem. All right. So again, descending order by exponent. So I'm going to start with my x squared terms. So 2x squared. Remember, we changed this, and the negative x squared leaves me with positive 1x squared, or x squared. The x term, I didn't have anything to combine it with, so I'm just going to rewrite it in my answer. And remember, we changed the sign, so it became a plus x instead of a negative or a minus x. I have a 3, and we changed the sign here to a positive 1, so a 3 and 1 gives me a plus 4 for my answer. Okay. Looking at the next one, again, remember, it's subtraction, so the first thing I'm going to do is change it to addition and change all of the signs in the second term. So here I have an x term and an x term. I have a constant and another constant. So I'm just going to go ahead and add those, combine my like terms now because I've already changed the signs. So I have a 17x and a negative 22x. 17 and negative 22 leave me with negative 5x. I have a positive 18 and a negative 7, which is going to leave me with a positive 11. And again, if you've forgotten your integer rules, go back and rewatch that video to refresh your memory. There's plenty of videos leading up to this, skills we're using that you can go back and refresh if you've forgotten, or you can check your notes. All right, so let's take a look at the last one. Again, first thing I do is I change this to addition, change everything to its additive inverse. Forgot the end parenthesis there. There we go. Now we're just going to combine our like terms. I have an x squared, I have an x squared, I have an x, and I have another x, okay? So 4x squared, negative 5x squared leaves me with a negative 1x squared, or negative x squared, because remember our 1's are implied. Negative 4x and positive 5x leaves me with a positive 1x. We're done. Remember, you can't combine those. They're not alike, so that's your answer right there. Again, if you have questions, please feel free to rewatch the video. You can always go back and rewatch some of the foundational ones as well, and you know where to ask your questions. Have a good night.